Hello, everyone, and welcome to this introductory webinar on the Relative Proficiency Index, often referred to as the RPI. Some quick housekeeping. There is a box for questions, and we'll try to address those at the end. My name is Joe Clays. I'm the Clinical Assessment Consultant for the Midwest region. But today, I'm here to talk about an underutilized metric that's often available on a number of our products. First, let me briefly introduce myself. I'm a former school psychologist. I taught some graduate courses in assessment, and I've been a trainer for a number of our popular assessment products. Here's a quick rundown of our agenda. It's a short webinar. We're going to focus on just one metric. However, I will be showing you how to access the RPI in the scoring platform and contrasting it with some other metrics, although we're not going to go into the weeds on how those particular metrics work. We'll wrap it up by showing you how to write up and discuss the RPI, and I'll give you an example of how it might be used in decision making. And then finally, we will try to address those questions that you might have. So the Relative Proficiency Index is available on a number of our Woodcock family of assessments. The Woodcock-Johnson 4 tests of cognitive achievement and oral language. It's also available in the Bateria, which is our Spanish version of the Woodcock-Johnson in the cognitive and achievement tests, as well as in the WMLS, both the English and Spanish version. And we also have the ECAD, which is the WJ4 early childhood test called the Early Cognitive and Academic Development. That test also has the RPI score available. Now, if you haven't heard of the RPI, or maybe you've heard of it, but you just weren't able to access it, or you never saw it on any of your reports, this is very common, first of all. It's in the scoring platform. This is WJ Score. So you've already logged in at this point, and it's under Reports. You'll find a drop-down menu called Score Report Template. Now, it's usually set to default. So if you select that menu, the first item will be called a New Score Selection Template. So if you click that, it'll generate an Add Template hyperlink. So we're going to click that Add Template hyperlink, and that's going to pull up a grid for you to select any number of scores for you to output. Now, today we're going to focus on the RPI, but you can name the template whatever you like, and it's going to show up in the menu from that point forward. So when you click that drop-down menu going forward, you'll see that name template. In other words, you don't need to keep opening the template and selecting these particular scores. You're going to create one and then use it. You might have a handful of them. For example, you might have one called LD eval, another one called progress eval, each of them having a different types of scores that you selected for those particular evals. One side note I should mention is that on the ECAD, it does refer to the RPI as just proficiency. Sorry about the inconsistent naming, but it is exactly the same metric. That is the RPI. So if you're using our ECAD, that early childhood version of our test, and you're looking to access the RPI, you're going to click on the proficiency item. So let's define the RPI. The RPI is a criterion reference statement about an individual's quality of performance. The scores are in the form of a ratio, with the denominator being 90 and the numerator varying from 0 to 100. The 90 is where the average peer demonstrates 90% proficiency on the task. For example, 45 over 90 on spelling indicates that the student is half as proficient as same age peers. Now, this is very different from what we're used to seeing. Very often in assessment, what we're looking at is relative standing in a group. In other words, we line up everyone in order based on some feature, whether it be their height, their performance on a particular task, or any other relevant dimension. And what we often find is that the results look somewhat like a bell curve, with most folks centered around the mean, and then fewer and fewer people as you move away from the mean. We derive scores from this distribution based on the standard deviation, but again, we're not going to go into the nuts and bolts of the standard score. Suffice to say that when you're looking at a standard score in a percentile, it's a measure of their relative standing in a group. It doesn't tell you how well they do on the task, only how well they did compared to some reference group which is often same-age peers. So let me just give you a quick example. If we were to have a quiz after this webinar, and on that quiz you scored at the 5th percentile, does that mean you did poorly? Well, maybe. That might be the case, but actually we don't really know. All we know is that 95% of participants did better. However, if it was a 100-item test and you got a 93%, that's not a bad score. But most folks did better than you. But if under a traditional grading system, that would be an A. And that's the essence of what we're talking about with the RPI. The standard score is norm referenced, and it speaks to relative standing in a group. The RPI is criterion referenced and speaks to the quality of performance. It's also change sensitive. In other words, going from 45% proficient to 90% proficient is a real meaningful change in performance. That's not always the case with standard scores. One useful way of understanding the RPI is to compare it to the Snellen index. As you may know, the Snellen index is a measure of visual acuity. A 20 over 200, for example, means that the individual has to be 20 feet to see what a person with normal vision can see at 200 feet. Again, it's a criterion referenced index. Now, imagine, if you will, that we were to use a norm reference index for visual acuity. Now, here's a grid here that has an example of this. This table shows the percentiles for each age and the level of visual acuity. And what you'll notice is that as folks age, their visual acuity declines. And what this means is that poor visual acuity actually becomes average when we use a norm reference metric. Now, that could be a problem for a lot of people. If we decided that you're within the average range for your age for visual acuity, so you don't need corrective vision. You don't need glasses or anything because you're in the average range for your age. I think we can see right away that that's going to be a problem. So just ask yourself, does it make sense to call someone with 20 over 70 visual acuity average, because that's where they fall in the norms? So in this example here, in the case of a 65-year-old person, which statement is more meaningful for understanding their performance? Joe is within the normal limits for his age, 55th percentile, or Joe has a visual acuity of 20 over 70. So let's bring it back to an academic example. In the case of a student's performance on a test in a specific domain, which statement or score is more meaningful for understanding their real-world performance or accuracy? Jane has a standard score of 79, which puts her at the 8th percentile rank, or Jane can perform on certain tasks at 25% accuracy, while others of her grade typically perform at 90% accuracy. The interpretation of the RPI is very straightforward. Just like the Snellen index, a 20 over 90 in reading means that the individual has 20% mastery or proficiency on a reading task in which the average grade mate would have 90% mastery. So again, it's a criterion referenced index of a person's reading skill. Again, it reflects the individual's proficiency on a task, which the average age or grade mate has 90% proficiency, and it predicts the levels of success on similar tasks. So the way we might write that up is, David is predicted to perform with 3% success on those writing tasks that the average grade mate would perform with 90% success. That would be an RPI of 3 over 90. Tara's RPI of 98 over 90 on math reasoning indicates that her performance would be very advanced compared to her aged peers. Here's some more sample statements to consider. Mark's level of proficiency on broad mathematics cluster was limited, 66 over 90. He is likely to find grade level tasks requiring mathematics to be very difficult. So again, these are some sample statements to illustrate how to write it up and talk about it with colleagues and parents. And I'm going to show you a chart later that shows where we got these descriptors. Let's look at another one. Sam's RPI of 21 over 90 on the phoneme grapheme cluster indicates that on similar tasks in which the average fourth grade child would demonstrate 90% proficiency, Sam would demonstrate 21% proficiency. Sam's knowledge of phoneme grapheme correspondence and spelling patterns is very limited. He is likely to find grade level reading and spelling tasks extremely difficult. Here's an example where we use the RPI in tandem with the standard score. So Luz obtained a standard score of 85 in passage comprehension, which is within the low range. Nevertheless, her RPI of 41/90 indicates that she is limited in her ability to comprehend brief passages, and that this type of task will be very difficult for her. So at this point, if you're still a little hazy on the RPI, let me give you a visualization that should help you grasp the intuition. Percentiles and standard scores provide relative standing. And in this race, you can see them clustered together with their corresponding scores. So again, the greyhound is up front, we have the horse in the back, and the Dalmatian and the sheep are somewhere in the middle. So somewhat like a bell curve, at least with the scores, we're representing it as a bell curve. But these scores don't show you how far from average the participants are. You know, take a look at this race right here. This race and this race are very different from each other. But you'll notice that the scores don't change. Again, this race, take a look at the scores, and let's compare it to this race and look at the scores. The scores are identical. Why does that happen? Why don't they change? Well, it's because their relative standing doesn't change. These different animals are all in the same relative order they were beforehand. And this is where the RPI provides additional information. Here's the race again, with everyone clustered together. Down at the bottom, you'll see the relative standing in a group metrics, standard scores and percentiles. And then at the top, you'll see our RPIs, which discuss more the quality of performance. And now when we look at this second race, again, we see that, again, on the bottom, those relative standing and a group scores haven't changed. But on the top, we can see that the RPI, which measures the quality of performance, it does change. The horse is doing much worse in this race than in the prior race, despite having the same relative standing in a group. So let's look at those again. So again, here's the horse in this group, 75/90. Not really that bad of an RPI score, even though the relative standing was low. But in this one, same relative standing, and we see that RPI score go down to a 58/90, which is a significantly lower score. And this isn't just theoretical. What we see is that scores on our tests do behave this way. We still have bell curves, but their shapes, which is often called kurtosis, can be very different. In fact, we have names for those different kinds of kurtosis. Not imperative that you know these, but the tall, thin ones we refer to as being leptokurtic, and if they're flat and low, kind of rolling hills, we call that platykurtic. But nonetheless, we do see different shapes of these bell curves, and that's what the RPI is providing us information about. It's telling us about how far away from that average performance the performance for this child, this individual, is on that particular task. So why does this happen? Well, it's because the scores are derived differently. Again, we're looking at different things. So a standard score, again, uses the standard deviation. That's how it's derived. But the RPI doesn't. And what you have to remember is that abilities develop differently. And people are more variable on some tasks. And people are variable on some tasks at different points in development. So, when a new task is, or a new type of academic area is being introduced, say we're introducing division problems in math, when it's first introduced, that dispersion of scores is going to be very different than, once most kids have started to master it, 3 or 4 years down the line, now what does division look like amongst that group of individuals? And you'll find that the dispersion of scores is very different later on. Sometimes some folks have said to me that, RPIs are always lower And that's not necessarily true. Let's look at some examples here. Here's an example of an RPI in reading fluency or retrieval fluency that has an 81/90, which is a pretty good score, but it has low relative standing. Now, why does that happen? Well, it typically happens on abilities that are acquired early in life, and they just don't change much over time. They have a flat growth curve. There's wide developmental and instructional zones, and there's a narrow standard deviation. In other words, people are less variable on the task. So that would be an example of that leptokurtic distribution. This is that tall, skinny distribution. When they're tall and skinny like that, just a slight deviation lower, a slight deviation higher really moves that standard score. You know, it'll go low very quickly, or it'll increase very quickly. But the distance from that average score doesn't change that much. They're all actually very close to where that average score is. So let's look at another example. On this one, we want to look at where the standard score is greater than the RPI. You know, for example, with math calculation. Now, here's an example where the standard score is 86, which, you know, it's on the edge, but, you know, if we use standard deviations, which not everyone does necessarily to define average, but if you're going to use standard deviations, an 86 would fall within those limits. Whereas the RPI, a 59/90, we consider that limited proficiency. And again, I'm going to show you a chart here in a bit that gives you some descriptors for these RPIs. So this typically happens on abilities that are rapidly changing. They have a steep growth curve. There's narrow developmental and instructional zones. And there's a wider standard deviation. In other words, people are more variable on these tasks. So again, if you were to imagine those distributions I showed earlier, this would be that wider group. This would be that race where all the animals are dispersed very, very widely on that particular task. That's where you're going to see the standard score being greater than the RPI. So whenever you see that, you know, in your mind's eye, you should be able to imagine that there is a wide dispersion of scores for, you know, other individuals on this task. So here are those descriptors that I discussed. If you're going to use RPIs, you probably want to have some sort of verbal descriptor. And we have charts with various kinds, you know, whether you're using functional, developmental, or proficiency-oriented descriptors. It's really up to you based on the type of task you're evaluating and maybe how the data might be used. Now, to wrap this up, I thought I might give you an example of how you might use the RPI. Using a norm reference score in this example, you know, if you look down there towards the bottom under the red line, you'll see that it's an 87, which falls within one standard deviation. Now, in many situations, that sort of score might not be a red flag. You know, this is a young student, and you know, maybe we feel like an 87 is within those normal limits. But then when we look at the RPI, we see that the performance is nearly half that of the average peer. Now, this might alert a team that the student needs intervention. And knowing that can be important because as this research study shows, if we were to provide a research-based intervention, the trajectory improves to near average performance of the average peer. And instead of, again, if we were to follow that red line, if we weren't to intervene, if we were to look at an 87 and say, well, you know, that's within our normal limits, that trajectory falls, you know, 2 or 3 grade levels behind when you go into those out years. So again, this can provide a team with crucial information about whether or not they need to make an intervention, step in and provide some additional services for the student. Anyway, I want to thank everyone for attending this webinar. Again, there's a box for questions. If there are any questions, go ahead and put those in there. We'll take a look at you. Okay, one question is, you know, can we use this for eligibility? Well, that's a very good question. First of all, I should say that eligibility requirements are going to be set by state departments in each of the 50 states. So, but generally speaking, we do define disabilities as being significantly different from average, which implies a norm reference sort of metric. That said, many states are moving to an RTI system. That's RTI, not RPI. So response to treatment interaction again, RTI, which allows for different types of evidence. Now, I can't say that you would or wouldn't be able to use an RPI in those situations, but as the previous slide suggested, there is a role for the RPI in the general education intervention setting. So again, in that setting, perhaps you would use an RPI to identify whether or not there needs to be maybe tier 3 supports for a child. So I think in that particular type of situation, you might want to use an RPI. Anyway, if there are any other questions, we will get those addressed for you and send out those answers. I hope everyone enjoyed this webinar, and I hope everyone has a good day. Thank you.